Hello. So we're going to chapter 7, and this is 7.1, graphing linear inequalities into variables. Okay, so first we're going to define a few things before we actually go and look at how do we graph these. So the graph that represents the solutions of a linear equation is a straight line. So here's our X and Y coordinate plane, and the solution of a linear equation would or can look something like this. Now, if we have a graph that represents the solutions of a quadratic equation, remember that quadratic equation looks something like this. The graph represents or is a parabola. Next, the graph that represents the solutions of a linear inequality is a half plane. So, um, depending on if you have less than or greater than, or if so with the less than or greater than, it's going to be a dashed line. Greater than or less than and equal to, or greater than and equal to, it's going to be a straight line. So one example could be something like this, and then the part is shaded. So this one would be less than, but it's half plane. It's not just a line, it's actually everything that is shaded over here. Okay, so let's look at how to graph an inequality. So rewrite the inequality as an equation and graph it as a boundary line. If the inequality is less than or greater than or less than, the line is dotted or dashed, just like I showed on the previous one. If the inequality is greater than or equal to or less than or equal to, the line is solid. Next, we're going to check a test point that is not on the line. So plug the values x, y into the inequality. If the statement is true, shade that side. If the statement is false, shade the other side. Okay, so let's look at an example here. We have graph the inequality y is greater than x. Now, the first thing I want you to do always so that you don't forget is look at this inequality. We see that it does not have that line under, the equal line under. So that means that this is going to be a dashed line. Our boundary line, like it says over here, where does it say? Rewrite the inequality as an equation and graph it as a boundary line. So y equals x. So what we're going to do here is we're going to go ahead and graph the boundary line. Again, it's a dashed line. Let me just plot points, couple up here. So it's going to be a dashed line like this. So this is our boundary line, which is the y equals x. Now, we're going to pick a point here. So an easy point. Now, 0, 0 would be an easy point, but it is on the line, so we can't pick that. Let's do 1, 0. 0.10. So our um, inequality is y is greater than x. So we're gonna use the 0 as the y and the 1 as the x from that point. Uh, is 0 greater than 1? No, this is false. So we know that we're going to shade the other side. So what we're going to do is we're going to shade this side right here of that line. If we had picked the point, for example, um, 0, 1, and we plug it in here, 1 is greater than 0. This is true. So we know that we're shading the side where the 0, 1 is, which we already did. Okay, let's move on to the next example. So graph the inequality 8x plus 3y is greater than or equal to 24. Okay, we have an equal sign here. So that means that we are drawing a solid line as the boundary line. Now, our boundary line, we're going to set this to equal. So 8x plus 3y equals 24. Now, we don't have it in a slope intercept form. We can convert this to a slope intercept form, or what we can do is we can look for the x and the y intercepts. So our y-intercept would be x equals 0. So plugging it in, 8 times 0 plus 3y equals 24. We get y equals 8. So 0, 8 is one of our points. So 1, 2, 3, 4, 5, 6, 7. 0, 8 would be here. Then we can do y equals 0. So 8x plus 3 times 0 equals 24. Well, 24 divided by 8, x is going to be 3. So 3, 0 is our x-intercept right here. So we know that this is a solid line, and now we can draw the line between these 2 points. Let's see how this is going to go. Okay. So that is our boundary line. Now we need to figure out, are we shading above or below? I highly recommend if the origin 0, 0 is not on the line, I always recommend plugging that in because that's the easiest point. 8 times, so 0, 0, 8 times 0 plus 3 times 0 is greater than or equal to 24. Remember, we're taking the inequality here. So 0 is greater than or equal to 24. That is false, which means that we are shading the other side where, so not the side where the 0.00 is. Okay, let's look at the next example here. We have y is less than or equal to 4. Again, we have that equal sign right here. So that means that we are graphing a solid line. The boundary line is going to be y equals 4. Okay, so y equals 4 is going to be a vertical line right here going this way. Not vertical, I'm sorry, horizontal line is what I meant to say. It is a horizontal line. So this line is y equals 4. Now, again, we're going to pick a test point. 0, 0 is not on the line, so we want to use that because that is the easiest point. So our original inequality is y is less than or equal to 4. 0 is less than or equal to 4. This is true. So we are shading the side where the point 0, 0 is. Okay, next one. So what we've looked at here is just one inequality. Now we're going to look at a system of inequalities. So the solution to a system of inequalities is the intersection of the solutions of the individual graphs. So we've got here two um, inequalities. We have x plus y is greater than, or less, I'm sorry, less than or equal to 4. And we have x minus y is less than 4. So let's look at the first one and look at the boundary line. So the boundary line is going to be x plus y equals 4. It has to be a solid line because it has that equal sign right there. Not a 4. I said 4, but then wrote 0. Okay, now this one is easy to put in the slope-intercept form by just moving the x to the other side. We get y equals negative x plus 4. So we know that our y-intercept is going to be the point 0, 4 here. So 1, 2, 3, 4 right here is our y-intercept. And then our slope is negative 1. So that means that we're going, if we go 1 up, we go 1 to the left. If we go 1 down, we go 1 to the right. Um, so this is gonna look, oops, okay, that's not a straight line. It should be, there's this point is not on the line. Okay, something like this. And that was a solid line. Okay, now, where are we? We're gonna, or which way are we shading? We're gonna use the 0, 0 as a test point because that's just easy. So 0, 0, we're plugging it in into the inequality. 0 plus 0 is less than or equal to 4. Well, yes, 0 is less than equal to 4. Less than or equal to 4. That is true. So we're shading. And now we want to shade it not really heavily because we have the other line that we're going to be shading as well. So we have x minus 4 is less than 4. We're going to set that to an equation so that we can get the boundary line. I'm going to do the same thing, move the negative x to the other side so we get negative x plus 4. Now, dividing by negative 1, every single one of these to get rid of that negative in front of the y, so we get y equals x minus 4. Okay, so our y-intercept is going to be 0, negative 4. 1, 2, 3, 4 right here. And our slope is going to be 1. So 1 up, 1 to the right. 1 up, 1 to the right. Right here. Now, this does not have that equal sign. So this is a dashed line. So don't forget to check that when you're graphing. Something like this. Okay, which way are we shading? We need a test point. We're going to use that 0, 0 as the test point again. So 0, 0, plugging it into the original equation. 0 minus 0 is less than 4. Well, 0 is less than 4. This is true. So whatever side 0, 0 is, we're going to shade that part right here. Now, our solution for this is where we shade both parts. So if we look at, this is the area where both parts are shaded. So that is our solution. Actually, we should, like, 0, 0, this part is shaded for this line as well. But the part that covers both shadings, that's our solution, and that's it. That's how we're gonna just show that this is it. Okay, next one we've got y is greater than 2x minus 3. We're gonna set that to be an equation. So instead of the greater than, we're gonna write equal to. It has the greater than only. So this is going to be a dashed line when we're graphing it. Well, this is already in a slope-intercept form, so we can just go ahead and plug in our y-intercept 0, -3, and then our slope is 2, which means that we're going to go 2 up and 1 to the right, 2 up and 1 to the right. And this is going to be a dashed line when we are dashed or dotted when we're graphing it this way, and then it goes this way. Okay, again, the point 0, 0 is not on the line, so we want to use that as a test point. So 0 is greater than 2 times 0 minus 3. 0 is greater than -3. That is true. So we're shading everything that's on the same side as that 0, 0. Next, we're going to look at the other one. So we have y equals -x plus 6. It does not have the equal. It only has the inequality sign is less than. So this is going to be a dashed line as well. And it is in slope-intercept form. So we know that our y-intercept is going to be 0, 6, 1, 2, 3, 4, 5, 6. There we go. 0, 6. And our slope is -1. So 1 up, 1 to the left. That went too far left. Right here. 1 up and 1 to the left. Then 1 down and 1 to the right. Down and right. Okay, and again, it should be a dashed line. 2, 3, 4. Like this. Now, which way are we shading? We're again going to use that point 0, 0 because it is not on the line. So 0 is less than -0 plus 6. 0 is less than 6. So it is on the same side as where the 0, 0 is right here. So again, the area that is our solution will be the one that is shaded by both. So right here between. Okay, next one is use the same process when graphing a nonlinear system of inequalities. Um, so the exact same thing as we can see here, we've got y is greater than or equal to x squared minus 4, and then we have x minus y is greater than or equal to 2. So we're going to start with the quadratic. We're still going to set the boundary line y equals x squared minus 4. And this is going to be a solid because it has that equal sign. Okay, for us to graph this, if you're not sure where the vertex is and where the points go, just go ahead and plug in points. So we're going to plug in 0, actually y, and then, hold on, what am I doing? X and y equals x squared minus 4. Here we go. So x is 0. So y is going to be 0 squared minus 4, which is -4. Then I'm going to plug it in x equals 1. So 1 squared minus 4 equals -3. X equals 2. 2 squared minus 4 is going to be a 0. So our first point is 0, 4, 0, -4. 1, 2, 3, -4, right here. Our next point is 1 and -3 right here, and the second one is 2 and 0. Now, our 0, -4 is the vertex, so the points are going to be on the exact same spot on the other side of the y-axis. So right here. It's a solid line, so we're just going to go ahead and graph that line right here, like that. Now, we need a test point for this one. Again, the point 0, 0 is not included on the line, so we can always use that. So 0 is greater than or equal to 0 squared minus 4. 0 is greater than -4. This is true. So we're shading the inside of the parabola here, like that. Okay, so let's look at the line that we've got here. The boundary line is gonna be x minus y equals 2. So we're just switching the inequality sign to an equal sign. It is going to be solid because that has the equal as well. I'm gonna just go ahead and move the x to the right and then divide by -1. So changing the signs, and I have it in slope-intercept form. So my y-intercept is -2, so it's going to be right here. Then our slope is 1, so we're going to go one up and 1 to the right, 1 up and 1 to the right, 1 up and 1 to the right. And this is going to be a solid line going like this. Now, we need a test point. Again, 0, 0 is not on the line, so we can go ahead and use that as a test point. So we have 0 minus 0 is greater than or equal to 2. Well, 0 is not greater than 2, so that is false, not true. So that means that we're shading everything that's on the other side of where the point 0, 0 is. So now with this, you can see that the only thing that is shaded for both is going to be this area right here. So that is our solution for this one. Okay, that's it for this lesson. There is going to be another one with 7.1 applications. So there's going to be a second video for 7.1, but just as a heads up. But this is what we got for this lesson. Bye.